Okay, for what we have in the next portion, okay, we looked at these two particular systems. Now, in terms of taking what we have in row reduction, and we have these particular matrices, and okay, so if we look into the case of reducing this 2 by 2 matrix, okay, so again, just going back to tools, tutors, linear algebra, okay, and you could again go to linear system solving, but here, since we're looking at reduced echelon form, again, this would be the what we refer to as the Gauss-Jordan elimination, okay. And here, if I make it into the 2 by 2 matrix, so if I were to edit the matrix, okay, and so I'm going to make this into a 2 by 2, and I'm just going to put in numbers. Now I'm going to make an adjustment very shortly. So we have top row we have 3, 5. Bottom row we have -2, 7. I click on display. Now I'm not interested in that line or solving equations. And so if I just take out the augmented, okay, so I have 3, 5, -2, 7, 3x of 1 plus 5x of 2, -2x of 1 plus 7x of 2. Again, this is already a square matrix, okay, and that just automates the formatting, okay, but so you don't need to click on the square, okay, so this is what we have on display, and so just closing out, and if I convert, okay, to reduced echelon forms, they have next step, and one more step after this, so you have 1, 0, 0, 1, okay, and if you want to view the properties, okay, so you have the row echelon form or reduced row echelon comes out to 1, 0, 0, 1, okay, and if you're looking at, say, like the row space and the rank, okay, you have rank is equal to 2, and like what we have been looking at, like for the column space, you have the basis for the column space, again, where we have 3, -2, 5, 7, and for the null space, or the basis for null space, okay, so you have, again, we had the rank to be 2, and that's the same as the number of rows and columns that we have for the original matrix case. So there was no value for what we had in the case of the dimensions of the null space of this column. All right, now if I change the matrix over to what we have for the next item, and for what we have here, okay, now the dimensions, okay, instead of a 2 by 2, we're going to have a 3 by 5, okay, and I do not need to put this as an augmented matrix because we're not looking at solving an equation, okay, so just taking what we have here. So for what we have in number 4, so you have 1, 2, 3, 2, 1. Second row we have 1, 3, 4, 2, 6. Last row we have 3, 2, and we have -2, -3, and also 5. Okay, and so if I put this on display, okay, so we have again, so this is what we have for the matrix, and this is what we would have for the variables view, and I'll just go ahead and close this out. And if I put this in terms of reduced echelon form, I'll just go ahead and click all steps. Okay, so we have for this bottom matrix, okay, this is going to be the reduced echelon form. So we have viewing the properties. Okay, so this is the reduced echelon form, and we have for the column space, okay, we have 3, and I just want to mention, okay, for the row space and rank you have 3, and the column space and rank, okay, that would also be at 3. So you're going to have a rank of 2 for the null space of this matrix, and we have, in this particular case, this would be the basis for the null space. All right, and if you notice, okay, we have for changing the matrix, the maximum number of rows allowable in this particular display, we have to be at 5. So the maximum you can go out would be 5 by 5, and let's go ahead and close out. Okay, but now there is a way. Say if you have a matrix that is very large, and let me give you just kind of like taking this last matrix we dealt with. What you can do is that you can build a matrix, okay, and have starting out with less than symbols. Okay, so you have just like your opening statement, then we have again less than symbol. And if I were to put this on display in terms of separating column by column, okay, so we have first column that was at 1, 1, 3. So you have greater than sign closing out for the first column, and we have and then separating the first from the second, we have the entry for the elements in the second column. So you have 2, 3, 2, close out, and then to separate from the third column we have at 3, 4, -2, close out, and then separating. So you have the vertical slash that separates by column, and we have for the fourth column we have 2, 2, -3. Got vertical slash, and then we have with the fifth and last column we have 1, 6, and 5. Then you have closing out, and then closing out for what we have in this particular matrix. Okay, so just checking the entries. All right, so this is what we have here: 1, 1, 3, 2, 3, 2, 3, 4, -2, 2, 2, -3, and we have 1, 6, and 5. Okay, and if you were to go over to solvers and forms, what you can do here is that we have with the row echelon form, and we have for the reduced. And if you notice, we have the same bit of history to repeat. So you have, this is again just like what we have with the tutors. You had that output. Guess what? With this method, we have this output likewise. And for what we have in the case of this last matrix, again, this is going to be beyond the capacity of what we have for the tutor portion. And in fact, we have 6 rows and 7 columns. So we have here for the last matrix. All right, again, it is beyond the tool's tutor capacity, but if I enter like what I did in this last case, again, so you have all the rows and columns, and again you have first column we have at 1, -2, -2, -4, -2, -4. Second column we have these entries, and we have just putting what we have on display. So you have 1, 2, 3, 4, 5, 6 rows, 1, 2, 3, 4, 5, 6, 7 columns. And if I put this in reduced form, so if I go over to solvers and forms, row echelon form, reduced, and this is going to be our output. Okay, pretty tricky.